Good morning, everyone. Welcome back to Pre-Algebra with Miss Betsy. Today we're going to be talking about how we multiply decimal numbers. I'm going to be using as my text Pre-Algebra for Christian Schools. It looks like this. It's the first edition. It's not the second edition. The two are not compatible as far as the layout of the lessons go, but you can still learn regardless of which edition you have, and you actually don't even have to have the same text that I'm using because you do decimal multiplication the same way. If you're using my text, however, we're going to be on page 90. It's section 3.5 and it's entitled Multiplying Decimals. So let's pray. I'll have a lame joke for you and we'll get started. God, you are awesome, and I stand in amazement at the love that you extend to us and the involvement that you have in our lives. Father, I ask that you would help us to be attentive today, that I would teach clearly, and that the people on the other side of the camera from me would be able to comprehend this material and continue to make progress in the class. Father, thank you again that you love us, and I pray in the name of your Son, Jesus. Amen. Okay, lame joke today is, can you tell me what is out of bounds? What is out of bounds? Well, that would be an exhausted kangaroo. He is out of bounds. Multiplying decimals, this should be just a simple, really straightforward review for you guys. As long as you know how to do regular multiplication with whole numbers, even if you've forgotten how to do decimal multiplication, you'll see that it's very simple little rule that you need to memorize, and then you have no difficulty. So let's say that we're going to take two numbers that we multiply together, and I'm going to happen to select 25 times 25 because you will be beginning to memorize what they call perfect squares. Perfect squares are where you take one number, multiply it by itself. The factors, the two factors of the number are the same, so 9 is a perfect square because you can say 3 times 3 is 9. 16 is a perfect square because you can say that 4 times 4 is equal to 16. Now, of course, 1 times 16 is 16, 2 times 8 is 16. But the fact that you can use the same factor twice, 4 times 4 is 16, is what makes a number a perfect square. So the perfect square that I'm going to take is 25 squared, which is 25 times 25. And when you do that multiplication out, you end up with 625 as your product. 5 times 5 is 25, carry 2, 125. As I talk to myself here, and I end up with 625. Every single one of you understands how we arrived at this 625. Well, now let's play around a little bit and see what happens if, instead of saying 25 times 25, I have 25 times 2.5. Pretty similar, except we just have a decimal point. Instead of multiplying by 25, it's multiplied by 2.5. Our answer, 25 times 25, is still 625, but the fact that we have this decimal point here changes the whole equation just a bit. And our solution here ends up being 62.5. Just going to highlight that with the green. And I really don't like the shadow in here. Let's see if this makes it any better. Having issues with my lighting this morning. Not sure that I like it either way. So we'll move the light back up here. Deal with the shadow. Now, let's say that we're going to have another change here. 25 times 0.25. All right. Same two factors, we just have the decimal point located differently. And this answer, again, 25 times 25 is 625. But the decimal point Now, the location makes this be 6.25 or 6 2500ths. Well, I'm sure you know what I'm going to do next, and you would be correct. What if I have 2.5 times 0.25? 25 times 25 is the same thing, 625, but this time our decimal point has moved again. And our solution, or our product, is 0.625. Well, I'm running out of places to put this decimal point, but I have one left that I'd like to use. I have 0.25 times 0.25. 25 times 25 is 625. Where are we going to put our decimal point this time? Well, watch this. We have as our answer 0.0625, or 625 thousandths. Now let's go back and look at this and see what I've done. No decimal points here. Decimal point doesn't show up here, though of course the decimal points, you can always add a decimal point and a 0 at the end of a whole number. And while it has a technical difference in math and science, when you're talking about precision, 625 and 625.0 essentially means the same thing. For our purposes, they're identical. Now we move over here and we have one decimal point. Where's that one located? It's right there. How many places do we have to the right of the decimal? We have one place. We move to our second example. How many places are there to the right of the decimal in total? In our two factors, we have 2 decimal points. And we have a total of 2 places to the right of the decimal point. How many decimal points do we have in our next example over here? Decimal places. When I say decimal points, how many places to the right of the decimal is what I'm talking about. Well, there are 3 decimal places to the right of the decimal here. Combined in the factors, 1, 2, 3, and look at this, 1, 2, 3. You have 3 places to the right of the decimal in our product. This one right here, you know exactly where I'm going. 1, 2, 3, 4. You have 4 decimal places located to the right of the decimal points in those factors. 1, 2, 3, and we did what they call annexing a 0 to the left of the product. 4. So that we now have 4 spaces, 4 decimal places to the right of the decimal point in our product. And this is illustrated or defined here in our book on page 90. And it says, you multiply with decimals much like you multiply with whole numbers. Study the following steps. Multiply as with whole numbers with what I did. Count the total number of digits to the right of the decimal point in the factors. What are factors? Remember that factors are the numbers that you multiply together to arrive at the answer to a multiplication problem, and that answer is called the product. The total number of digits, total number of digits to the right of the decimal point here in the factors is 1. Now it says, place the decimal point in the product so that the product has the same total number of decimal places as the factors. 1 decimal place, 1 decimal place. We counted the digits here to the right of the decimal point. 1, 2, 2 places, decimal points, 2 decimal places to the right. We located our decimal point in the product, which is the solution, so that there are also 2 decimal places to the right of the decimal point. Counted the total number of digits to the right of the decimal point here in our factors. 1, 2, 3. We locate the decimal point, so we have 1, 2, 3 decimal places to the right of the decimal point in the answer. Final example, 0.25 times 0.25, 1, 2, 3, 4 places to the right of the decimal point total in our factors. So our solution, or which is our product, has 1, 2, 3, 4 decimal places to the right of the decimal point, and you have to add that 0 here in the front as a placeholder in the tenths, so that you know that you're talking about 625 thousandths, because without that 0 there, you would, 625 ten thousandths. I think I called that incorrectly. Tenths, hundredths, thousandths, yeah, 625 ten thousandths. I think I called that 625 thousandths the first time. This one right here is 625 thousandths. This is 6 and 25 hundredths. This is 62 and 5 tenths. This is 625 ten thousandths. So you need that 0 in there so that you know how to name this decimal number correctly. Okay? That's all there is to multiplying decimal numbers. So let's look at this skill check right quickly, and then we're going to talk about estimating with decimal numbers. I'm not going to do the long division. I want you guys, long division. I'm not going to do the multiplication. I want you all to do your multiplication by hand. This is problem number 1 in the skill check. (9.7) times 0.6. Actually, I'll go ahead and do it. 6 times 7 is 42. Carry 4. 6 times 9 is 54, and 4 is 58. See, I did this multiplication exactly as if I were multiplying 97 times 6. Now I have to determine where I'm going to locate the decimal point. There are 1, 2 digits to the right of the decimal point, so I locate my decimal point in the solution so that there are 2 digits to the right of the decimal point. Problem number 2. 2.68 times 5.9. I'm going to just magically come up with the solution here. 15812. Don't punch it into your calculators. Give yourself some practice with multiplying this out by hand. Now the exception to this is some of you I've said, I understand what's going on, go ahead and use your calculators. Of course you have permission to do that if you've spoken to me separately. How am I going to know what to do with my decimal point? Count the total number of digits to the right of the decimal point in the factors, and we have 3. Locate your decimal point so that there are 1, 2, 3 decimal places to the right of the decimal point in the answer. That's all that you do. Okay, let me just do, I guess, problem number 4 from Skill Check. This one is 43 times 55 4/10. This is what this says in your book. Make sure that when you set your vertical multiplication up, you put the number with more digits on the top. 55.4 times 43. When you do your multiplication, you'll come up with 23,822. 2, 3, 8, 2, 2. Where do you locate that decimal point? You're going to locate that decimal point so that there are the same number of digits to the right of it as are the total number of digits to the right of the decimal point in the factors. You have two factors here. Only one of them has a decimal point shown in the problem. There's only one digit to the right of it. So your solution has one digit to the right of the decimal point. The location of these decimal points has nothing to do with how big or how small the numbers is. The location of the decimal point is determined solely by the total number of digits that there are to the right of the decimal point in the factors. 1, 2, decimal point is located so that there are two digits to the right. 1, 2, 3, decimal point is located so there are three digits to the right. 1, decimal point is located so that there's simply one decimal point to the right. Now, they're going to ask you to estimate products when you are dealing with decimal numbers, and this is what you do. So we're going to have estimation involving decimals. And what are we going to do? At the top of page 91 it says, round each decimal to its largest place, then multiply. Round each decimal to its largest place, and then you're going to multiply. Sure wish I could write and face the camera at the same time. I do my best not to have my back to you, but when I have to write, there's very little I can do. Okay, so let's say that we have 38.6 times 2.1. 38.6 times 2.1. They want us to estimate. Estimate means do not come up with an exact answer for it. You don't multiply together and get the exact answer first and then estimate. You're going to round each number first before you multiply. Largest place here is in the tens. 38.6, of course, rounds to 40 because we look at the digit to the right of the 3. Because it is 5 or greater, the digit in the tens place is increased by 1. Now, how are we going to round 2.1? Its highest place here is in the units. The digit to the right of the 2 is 4 or less, so there's no change in the digit that is located in the units place. See, I just went to the parentheses here to indicate multiplication. So our estimated value here is 80. This is what they want you to do. Now let's just go ahead and see if we have a reasonable estimate. I'm going to go ahead and do the multiplication out here to the right. 2.1, 386, 2 6s are 12, 16, 17, 6, 7, 6, 0, 1. Yeah. Our actual exact product when we multiply these two decimal numbers together is 81.06, which is very close to the 80. that we got for our estimation. That's all that you do when you are estimating products that involve decimal numbers. Now, let's go ahead and do one more of those, one or two more of those from our skill set, from our skill check. Let's do number 8. These are going to be estimate. Problem number 8 in our skill check, 2.7 times 18.5. 2.7 times 18.5. We round each number to its highest place. 2.7 rounds to 3. 18.5 rounds to 20. If you're not understanding exactly what I'm doing in this rounding, go back and rewatch the video on rounding numbers, on where we're at estimating products, or ask mom or dad, or send me a text. 2.7 times 18.5 is approximately 3 times 20, which is 60. Problem number 9 on our skill check. 319.6 times 8.1. We round each decimal to the highest place, which is going to be the hundreds here and the units. And we have 300 times, hopefully they're going to do 10. 300 times 8. Did you hear what I just said? Hopefully they're going to round to 10. This is where it's different. 8.1 would round to 10, wouldn't it? 8, rather, would round to 10, but because this is a decimal number here, we're only rounding to the largest place, which is units. So it rounds to 8. How do we do this multiplication? 3 times 8 is 24. And you have your 2 extra zeros that you tack on at the end. 300 times 8 is 2,400, which is a close approximation to the result that you get when you multiply together 319.6 and 8.1. Problem number 10, we have 98.6 multiplied by 54.8. Okay, we want to round each digit, each decimal number here to its highest place. Highest place for 98.6 is the tens, but because this is a 9, when we round this, we end up with 100. 100 times 50 is how we are going to estimate how we're going to round these factors here. So we come up with an estimated product of 5 times 1 is 5. Then we have 1, 2, 3 zeros. With an estimated product of 5,000. Now when you're working on these problems and you're doing estimation of decimal numbers, your rounded numbers should be identical to what you have in your solutions guide. If you're having difficulty getting the exact number that you have in your decimal in your teacher guide, send me a text and we'll talk about it and see what's going on. Okay, the only other thing that they're emphasizing that they did not give you examples of in your skill check is what happens when you have more decimal points in the factors than you have more decimal places in the factors than you have in your solution. So let me just pull one right here for you. Again, from your example, this is 0.28 times 0.3. When you do that multiplication, 28, 0.3, 3/8 or 24, you get 84. But you have a problem because 1, 2, 3. There are 3 digits to the right of the decimal point combined in your product. You only have 2 digits available, so you have to add a 0, annex a 0 in front of that product so that you have 1, 2, 3, so that you have the same number of digits to the right of the decimal point. And anytime you have a number that begins, an answer that begins with a decimal point, you always put a 0 in front of that, and that makes it screaming obvious that you have a very small number that you're dealing with here. That's really all that's involved. That's, it's taken me more time just to go through this very slowly, I think, than it's going to take you to do your work. Just count up how many digits there are to the right of the decimal point in your factors. Make sure that you have the same number of digits to the right of the decimal point in your product, and you'll be fine. Shoot me a text if you've got difficulty with that. Otherwise, I'll see you on Friday.